In this video, we're going to do an introduction to compound interest. And I'm not going to give you any crazy formulas or anything like that in this video. Basically, what I want to do is just give you the idea of what compound interest is all about. How is it different than simple interest? Now, I think the easiest way to kind of understand this is by doing an example. So let's suppose you have you deposit $1,000 into a bank account that gets 8% annual interest. Now, I know that interest rate is very high, much higher than you could get in a bank, but let's just go with it for now. You deposit $1,000 in a bank account that gets 8% annual interest. How much money will be in the account at the end of 1 year? Okay, now this seems like a very simple problem, and it seems like, well, let's just take 8% of 1,000, and that would be $80, and then add that to the 1,000, and we would expect at the end of 1 year that we would have $1,080. Okay, but actually, this is a trick question. The correct answer to this is it depends. Okay, it depends. Now, what does it depend on? Well, it depends on how often the interest is compounded. If the interest is just compounded one time, in other words, if we have what's called simple interest, then you'll have $1,080. Okay, but if the interest compounds more than once, which is actually true for real bank accounts, it will compound a lot more than one time. How much money will you have? It turns out you're going to have actually more than $1,080. Okay, so let's look at some pictures here. So I've drawn some really timelines here. So let's suppose this represents 1 year time span. And at the beginning of the year, you have $1,000. And we'll look at the number of times the money is compounded. So let's begin with just one time. So this would be simple interest. Okay, if we take our 8% interest, how much money will we have at the end of the year? Well, basically, you need to take $1,000 and multiply it by 1.08, and you'll see you end up with $1,080. Okay, that's really simple interest. Okay, but banks don't calculate it that way. Okay, how do banks calculate it? We'll see in a second here. But let's suppose that the number of times the interest is compounded is twice. Okay, 2 times per year. So what that means really is instead of taking 8% for the full year, you're going to get 4% the first 6 months and 4% the next 6 months. Okay, so how much money would you have at the end of 6 months? Well, you'd have $1,040. Okay, you've gained $40 in interest. You basically take 1,000 and multiply it by 1.04, and you end up with this. Okay, now how much will you have at the end of the year? It's not going to be 1,080 because this 4%, we're not going to take 4% of our original 1,000. We're going to take 4% of our new amount, 1,040, and 4% of that is going to be more than 4% of 1,000. Okay, so how much do we have at the end of the year? Well, let's multiply 1,040 by 1.04, and let's see, what do I get? I get $1,081.60. Okay, so notice you have a little bit more money, not much, just $1.60 more, but you have a little bit more money than if you just had simple interest. So what was really happening there? Well, the key thing was our interest that we made, that $40 of interest that we made. When we calculated interest the second time, we calculated not only on our original 1,000, but we calculated on the additional $40 that we made. So in other words, interest itself is gaining interest. Okay, the interest is compounding on top of itself. Okay, let's do one more example here. Let's suppose we compounded 4 times per year. Okay, so basically every 3 months, you would take 2% every 3 months. Okay, we'd be compounding quarterly. Okay, up here this is compounding semi-annually. Okay, well at the end of the first 3 months, you'd have $1,020. Okay, basically take 2% of 1,000, add it to 1,000, you get this. Or another way of doing it is multiply 1,000 by 1.02. Now at the end of 6 months, how much would you have? Do you expect to have more than 1,040 or less than 1,040 or equal? Well, I expect to have more because I'm taking 2% of 1,020 instead of 1,000. Okay, and so it turns out you end up with $1,040.40. Okay, so you have a little bit more. Okay, and then multiply that again by 1.02, and at the end of 9 months, you have $1,061.208. If you rounded that to the nearest penny, it'd be 0.21. And at the end of the year, we have $1,082. Let me just write it out, 43216. Now we'd have to round this off to the nearest penny, but we'd have $1,082.43. Notice that's more than if we had compounded twice, and it's definitely more than if we had compounded just one time. Okay, so when your interest itself is gaining interest, you're getting what's called compound interest. So when we compound it twice or 4 times, that's compound interest. When you compound just once, that's simple interest. Okay, so notice a couple things you can see. The more times the money the interest is compounded, the more money you'll have at the end of the year. Okay, so what if we compounded lots and lots of times? So let's make a couple notes here. First of all, the more times the money is compounded, or the interest is compounded, the more money you'll have after 1 year. Okay, now let's suppose it's compounded 365 times per year. So in other words, daily, instead of just 1 time or 2 times or 4 times, what if it's 365 times per year? Or maybe 1,000,000 times a year, or 1,000,000,000,000 times per year? Okay, would you be really, really rich at the end of 1 year? Would you be like Bill Gates, or Warren Buffett? Well, it turns out, no, you would not be really rich unless you already were really rich, because there's a limit to how much money you'll have. Okay, the best that you can do is what's called continuously compounded interest. Okay, and continuously compounded interest, the way to calculate it, well, in this example, the way to calculate it is you take your $1,000 and you multiply it by E. Okay, now remember this E is 2.718. Okay, it's approximately. So recall, E is approximately 2.718. E to the 0.08 power. Okay, and what do you end up getting? Okay, well, let's bring up our calculator and see how to do this. Well, we type in 1,000, okay, times E. Now, how do you get E? Well, you probably can't see this very well, but E is this little blue right in here, right above the ln. So you type in second ln, you get E to the 0.08 power, and we'll hit enter, and what do you notice? $1,083. And if we round to the nearest penny, it'd be 29 cents. Okay, so let's write this down here, $1,083.29. Now notice, is that more than these amounts up here? Yeah, it was $1,083 and something. That's more than any of these amounts. So in other words, this is the best that you can do. If you compounded 365 times per year, or 1,000,000 times a year, or 1,000,000,000,000 times a year, you're definitely going to be getting more and more and more the more times you compound, but it's going to be getting closer and closer to this amount. So if you compounded, say, 1,000 times a year, maybe you'd have $1,083.28 maybe. Okay, or 1,000,000 times or 1,000,000,000 times, you're going to be getting closer and closer to this. This is the best that you can do. It's what's called continuously compounded interest. Now notice, isn't it kind of interesting that this number E comes into play? Okay, this is a very important use of this number E. Okay, well, in the next couple of videos, I'm going to give you some formulas for how you compute compound interest and continuously compounded interest. But this video, I just wanted to give you kind of a feel for what compound interest means. Okay, it means your interest itself is gaining interest. Okay, not just your original amount of money. Okay, one other thing I want to point out that we'll talk about later is that notice when we compounded twice per year, we ended up with $1,081.60. So it was almost like we really were making 8.16% interest. Okay, even though our interest rate was 8%, since we compounded twice per year, it was almost like we were making 8.16. So do you see this 8.16 here? If you move the decimal place over. So this is what's called the effective rate. Okay, the effective rate, or sometimes called the APY, the annual percentage yield. Okay, so your initial amount, if it's 8% and you're compounding twice per year, your effective rate will actually be 8.16. Now down here, when you're compounding 4 times per year, what was our effective rate here? Well, here it looks like it's 2.243216%. Okay, that would be the effective rate if you were compounding 4 times per year. And actually, if you're looking at continuously compounded interest, notice down here, we would have 8.329. Now, I think I rounded off a little bit, but 8.329%. That is the effective rate, okay, or the annual percentage yield for 8% interest if you're getting continuously compounded interest. And notice the effective rate is going to be greater than the original rate. Okay, the effective rate is greater than the original rate, the stated rate. And also in a future video, I'll explain how to calculate the APY, how to calculate the effective rate.